Okay, today I'm going to be going over how to calculate the current in a circuit with a given power source. And this is a DC circuit, that stands for direct current. And the current will be coming from this 10-volt source. And actually this is my second take of this video. The original video where we encountered some technical difficulties, so that's why everything is already pre-drawn. But I'll just go through everything again, so no worries on that. So we have a circuit here. I discluded all the ohm symbols in this because it just took up too much space. And so we'll go through this. We have lots of resistors here, and these resistors are 2 ohms, 3 ohms, and these are both 6 ohms. And you'll understand the circling once I get to that. But don't worry guys, this circuit may seem complicated, but in actuality, as long as we follow along with the proper order of doing these things, which is inside to out, and remember our resistor rules, which is in parallel, 1 over the equivalent resistance is equal to 1 over R1 plus 1 over R2, etc. And in series, it's the equivalent resistance is equal to R1 plus R2, etc. So in the next step, I'm going to redraw the circuit, because you should always redraw the circuit after you combine some resistors, and I'll be combining this set of resistors and this set of resistors. Okay, here is the circuit redrawn, and as you can see, I replaced those two sets of parallel with R1 and R2, and all the calculations are done out here already, because like I said, this is my second take. But so what happened is 1 over R1 was equal to 1 over 2 plus 1 over 3, and then the common denominator 6, 3 over 6 plus 2 over 6 equals 5 over 6. And since it's 1 over R1, you need to take the inverse of that, which is R1 is equal to 6 over 5, which is 1.2 ohms. And R2, same process, 1 over R2 equals 1 over 6 plus 1 over 6, since those were the values of the resistors, is equal to 2 over 6. So R2 equals 3 ohms, because that is just 6 divided by 2. And for this next step, it's going to be the most calculations in any of the steps I'm doing. It was just to limit the number of times I would actually redraw the circuit. So I'm going to be combining this set of resistors, this set of resistors, this set, and this set, as shown by the circles. So I actually have the next set right here, and I've replaced the resistors with R1, R2, R3, R4, and R5 to demonstrate the equivalent resistances. I'm reusing R1 and R2 just as a simplicity's sake, because I don't want to have to remember the number that I started at and keep incrementing and get the things like R20. So this next step will be R1, these are all just in series, so it's pretty easy. You just have to add them together. There's no taking the inverse or anything like that. It's just adding the resistances together, which is 1.2 plus 3 equals 4.2 ohms. R3 is equal to 2 plus 2 ohms, which is equal to 4 ohms. Then R2 is equal to 5 plus 5 ohms equals 10 ohms. R4, 5 plus 4, 9 ohms. R5, 3 plus 3, 6 ohms. And if you remember from the previous diagram, that's just what those values were, as you can see there. And now, for this next step, I'm going to be combining this set of resistors and this set of resistors, which are both in parallel. So I have this next step right here, and I've redrawn the circuit, 10-volt power source again, all the known resistance values, and we have R1 and R2, which replaced the two in parallel we had before. And those are calculations that are 1 over R1 equals 1 over 10 plus 1 over 8, which will, with a common denominator of 40, equals 9 over 40. And so R1 equals 40 divided by 9, which is approximately 4.4 ohms. Sorry if that doesn't look like a 4. Here it is written again. Now that might be a little hard to see, but just trust me, that's 4.4, not 4.9. Same process again for R2. And that's 1 over 9 plus 1 over 6, common denominator of 18. So it's 2 over 18 plus 3 over 18 equals 5 eighteenths. So R2 equals 18 divided by 5, which works out to 3.6 ohms. And for this next step, what I'm going to be doing is I will be combining these two resistors, because the next few steps here might be a little confusing, because you might ask, well, why can't I combine all three of these resistors in parallel first? And the answer to that question is, well, if you notice, these two resistors are in parallel with each other, but these two resistors are in series with this parallel set right here. This is how circuit diagrams can get a little confusing, but if you just take it step by step, like we're doing here, it makes the complicated simple, and you're able to solve almost any circuit problem. So I'm going to combine these two resistors, and I do that in the next redrawing. And at this point I had to change markers because the ink ran out of my Sharpie. So I redrew the circuit with the known resistance, placed the two resistors in parallel with R1. So R1, it's 1 over R1 equals 1 over 5 plus 1 over 3.6. And there's a little trick to your calculator to doing this. Instead of having to find the common denominator and go through all that, there's an easier way. You just do 1 divided by 5 plus 1 divided by 3.6. Get that answer. I believe this was about like 0.44, something like that. So, and then what you do is you take the inverse of that to get the value of the resistance, which is just raising your answer to the -1 power. And in this case, I got 2.09 ohms for R1. And we're almost done here. This next drawing, I will have combined these three resistors in series, so then I can combine these. So this next step, I've redrawn it here. And as you can notice, I replaced those three resistors with R1. And to calculate that, it's just the resistors in series rule, which is 7 plus 2.09 plus 8, which is equal to 17.09 ohms. So that's the value there. And then for the next step, and actually this is the second to last step before we find the equivalent resistance of the entire circuit. We're almost done. I hope you guys have stayed with me so far. So what I'm going to do is I'm going to combine these two resistors in parallel, and it will be our last combination in parallel for the circuit. Now I've combined them into R1. So R1, 1 over R1 equals 1 over 4.4 plus 1 over 17.09. And if you remember the calculator trick I just mentioned, get that answer, find the inverse, and you get the value, which actually works out to be approximately 3.5 ohms. So now the final step to finding the equivalent resistance. Combine these three resistors in series to get R1, add the resistances together, and then you get R1 is equal to 17.7 ohms. And now we have one resistor, we have a power source, and we know both of these values. And initially I'd set out to find the current in this circuit. And to do that, if you remember, almost IR, and then I equals V over R just through some algebraic manipulation. So you get I equals 10 volts, 0.7 ohms. So I is equal to 0.565 amps. And there you have it. That's the current running through this circuit. If you have any questions, leave a comment, and I will try to answer it as best as I can. Thanks.